Good morning, everyone. Welcome to BMC LiveTube event. We have Jay Lipovich here today to talk about how to view batch stream performance in capacity management for mainframes visualizer. Hi, Jay.
Hello, Priya. How are you?
I'm good. How are you doing?
Just fine.
Thank you, Jay. It's all yours. Take away, please.
All right. Thank you. Welcome, everyone. Thank you for joining. What we'd like to discuss, as Priya said, is how to view and analyze batch stream performance using the visualizer component in CMM. And this is an introduction to the capabilities so that you can see what's possible and to enable you to do analysis of batch stream performance if you have issues with your systems. So we'd like to begin by discussing real briefly why we analyze batch streams and why we care, and then cover the data that's required and what you do to set up the definitions of your batch streams. And then we'll go through an example in Visualizer of doing batch stream analysis. So to begin with, why do we care about batch? Batch is out there and has been used for decades, and for a lot of cases, it tend to be viewed as not that critical. But we know that in most organizations, there are processes that are critical for operations. In some cases, they're required to be run before onlines can start up for the day. In other cases, they are used to update operational information. So think of, for example, an inventory control update that's necessary before the stores and the POS systems are available for sales the next day. And then in some organizations, they're part of industries where there are regulatory and compliance requirements in which they have to deliver certain reports by certain times, and the failure to do that can result in monetary fines. So those are our business aspects of batch processes. On the IT side, one of the things we've learned is that batch processes actually drive the MLC peak 4-hour rolling average for a lot of organizations. In the BMC mainframe survey, which included the responses of over 1,100 mainframe professionals, over 60% of the respondents said that their MLC peak is driven by batch. That may be nighttime batch, it may be daytime batch, or it may be month-end batch. So if those batch processes start to consume more CPU than they typically do, they can drive up the MLC peak, and that results in more cost to the organization. So both from a business point of view and from an IT cost point of view, it may be necessary to analyze and troubleshoot batch streams in your organization. So how do we go about doing that in CMM? In addition to the standard SMF and CMF or RMF data that we use, there are some other records that you want to make sure you include. You need to enable the interval SMF recording, and then include the type 30, subtype 2, and subtype 3 interval records, as well as the type 42 subtype 6s. This gives us the information we need to understand the performance of the individual batch jobs. Then you define how you want those batch jobs to be grouped together. In CMM, we call this construct a suite. And suites are just groupings of batch jobs or started tasks in a way that you've defined. So you create these definitions in the Universal Information Exchange, or UE, as we refer to it. That is the batch job that runs the data analysis on your system data every night and produces the information for the database. And in defining the suites, there's a lot of flexibility in how you do that. So you can do it with job name, for example. If you had an inventory control process and all of the batch jobs used a naming convention of INV something, you would define a suite that you might call inventory, and the definition of the criteria would be job name is INV wildcard. So UE would analyze all the jobs, grab all the jobs meeting that criteria, and group their activity together so it's possible to view what's going on within that inventory suite. Now you can also use account information, which can be positional. You can use wildcards. You can examine the subfields for that information. And in addition, service class names, report class names, initiator class, and sysid. So with all of these options in defining suites, it's generally possible to get a suite that is defined that represents the flow of activity for a particular business process that you're interested in. Having done that, you use the visualizer component of CMM to do the analysis. The steps are pretty simple. You focus the database on the date and time and suite of interest. You select the activity profiles for viewing the suite information. On that graphic diagram, you identify the system of interest, the time period, and you can use drill down then to do analytics, including looking at the flow of jobs by their start time, looking at the various job metrics that are available, or looking at all of the metrics for a job or a group of jobs. So what I'd like to do is go through an example in Visualizer of looking at a specific batch job stream. So we're in the Visualizer product, as I mentioned. We begin in the database. In this case, we're going to look at January 16th. It's an overnight batch flow, so it starts at 7 p.m. and it concludes at 7 a.m. on the 17th. DB2A is the system we're particularly interested in, and we have the ability to select the suite of interest, in this case, batch IOA. Then we go to the graphics menu, look at profiles, and in this case, we want to look at the activities for a selected suite because we know the suite that we're interested in. That renders this graphic. Now, let me spend just a minute explaining what it is that's showing up here. At the bottom, on the X scale, if you will, is the time period we selected. You see 7 p.m. on the 16th, flowing through 7 a.m. the next day. On the right hand is the suite that's of interest. We selected batch IOA, and the various systems on which those jobs ran. And as you can see, the majority of activity shown by these bars on the DB2A level occurred on DB2A. Now, what each of those bars represents is a job or group of jobs, and the size of the bar is the start and end time. The color coding is based on a metric that's been selected at the bottom. So in this case, CPU seconds has been selected. The color scale is shown on the right-hand side. And so all of the color coding is based on CPU seconds in this color scale. Now we could look at all of the jobs that are running on DB2A, but in this case, we're particularly interested in the jobs running from about 4 a.m. to 6:30 a.m. When I click on that bar with a single click, you see at the bottom, that's 150 jobs running from 4 to 6:30, and you see the average metrics for all of those jobs. And what we really want to do is understand the individual jobs, perhaps. So by double-clicking on that bar, we drill down automatically to those jobs in that time period. You'll notice at the bottom, we're now focused on 4 a.m. to 6:30 a.m. And we now see the individual jobs, and these jobs are sorted based on the metric that was selected at the bottom. So they're sorted based on CPU seconds with the high CPU second users right at the top. So this provides an automatic analysis for you. You don't have to sort through 150 jobs to figure out which ones are using the most CPU. Visualizer graphics can do that for you. Now, frequently analyzing a suite of jobs is best done by looking at the flow. So Visualizer lets you do a lot of changing of the views very easily to see what you need to see about flow. The way we do this is a right mouse click in a white space area, so not on the graphic itself. And you can see we're displaying CPU seconds. That's how they're color coded. And the order that they appear on the left-hand side is CPU seconds. We're going to change that. So we'll change that to start time. And now we're going to have all of the jobs listed based on their start time. And you can see we started at 3:54 in the morning, and you can see the flow of jobs as they start to execute. And using the scroll bar on the right, I'm going to scroll down through the flow of jobs. And you get to see the flow throughout this whole process of jobs. Typically, you will have jobs where there are dependencies, and dependencies show up. For example, here I've highlighted a small job that runs for just a minute, and that is a dependent job before this job can run. So as you start to look at delays, you can look at jobs that are waiting for another and see if there was excess time being spent. Now you'll notice this big blue bar. Blue, again, the color is based on CPU seconds, so we know he didn't use much CPU, but he ran for almost an hour and a half. So by clicking on that job, at the bottom we get to see all of the metrics for that job. And we see 0.78 CPU seconds, not a big CPU user, but we see 4,586 in swap wait. So if we're trying to understand what was going on with that job, we have kind of an instant picture of what was happening. And if the job happened to abend, it would display the abend code over here on the far right. So I'm going to scroll all the way to the bottom. Typically what you'll look at, and if you're examining a suite, it has a targeted end time. And in this case, if the targeted end time was 6:15, but it ran longer than 6:15, this final reconciliation job, which typically runs 15 minutes, was running a lot longer. And it was experiencing some waits, and we can see that here. Now, it's possible to use that sorting and order by to display other metrics. So in this case, let's look at that swap wait. See, we saw that one job had a lot of swap wait time. Let's see if others were experiencing it. And we'll still leave it, we'll make it ordered also by swap wait. And when we do that, I'll scroll up to the top. Now the colors are based on swap wait because that's what we selected. And you can see there's that one job with significant swap wait. Then there's a series of jobs with some amount of swap wait, and then most of the rest of the jobs didn't experience any swap wait delays. The idea in Visualizer is to help you quickly correlate a lot of metrics and visually focus in on the thing that's most critical to what you're doing. So to summarize, make sure you're collecting the correct data to be able to see this level of detail. Define some batch streams that are of interest to your organization. Use the suite commands in UE, and we'd suggest starting with 1 or 2. And then using the profile graphics as well as the suite graphics, which are also available in the graphics menu, go explore what's available and how you can see the performance of your suites in the Visualizer displays. Then expand your suite definitions to include the critical suites that are important to your business. By doing this, as I mentioned, you can have the data available every day, and when a question comes up about what happened yesterday to a particular batch stream that's critical to the business, you can go right to Visualizer and analyze what's happening. More information on how you use suites, how you define them, is available in the Universal Information Exchange 1.9.10 user guide. So at this point, Priya, let's see if there are any questions.
Wonderful information, Jai. I'm looking at our chat window and looks like no questions for this session. So that brings us to the end of this session. And I want to thank you, Jai, for a great session, and let our participants know that your feedback is valuable to us. And please send us your comments. And if you want to notified with the upcoming events, please subscribe to this channel. And if you like what you saw, please hit the like button or thumbs up. All right, we'll see you in our next near future live event session featuring BMC products. Thank you. Bye bye now.